Yeah, comes on everyone. Let's start off. Great. So last thing that we did was the power rule. Other scams on. Let's see something on this. That's your power rule. So let's say we got a rectangle here. The length is given by 10.0 centimeter plus or minus 0.2. The breadth is 5.0 centimeter plus or minus 0.1 centimeter. Find error in percentage of area. Yeah, let's get this thing. It's a straightforward question. Maybe I can give you one more like this bit. Plus or minus 2.0 centimeter. Yeah, find the percent error in area. One more thing, yeah, this power rule, right, is valid only for very small errors. Because when you're differentiating, right, you're saying that dp and dq, these are very small quantities. When I say small errors, we're talking about 1%, 2%, not more than that. Yeah, let's get these two cases. So what's the answer for this? So look at the first one. Direct formula substitution. So we have area is equal to LB. So if I use the power rule, this will be like dA by A is equal to dL by L plus dB by B. How do I get that? Put a ln on both sides and differentiate. So the percent error in A, so this will be dL will be 0.2 by 10 plus 0.1 by 5. If you want percent error in it, just into 100. That would be 2 plus 2. So that's around 4%. Yeah, that's a 4% error, which is still kind of acceptable. But if you do the same thing for the other one, right, you will notice you get a pretty big value. How much was the error? 2 centimeter. That's almost 20% error there. So 2 by 10 plus 1 by 5 into 100. Yeah, this would be like what? 2 by 10, 1 by 5, 1 by 5. That's 40% error. So this would be wrong. This is not acceptable. This is a very large error. Power rule is not valid. So that itself, the moment you see the question, you should say like, there is no way you can solve this. The power rule is not valid here because the errors are too large. So this thing is an error of 20%. This is also a 20% error. Power rule is not valid. So first thing, if you do experiments like this, and if you go and take the value, the person is going to say, go and redo the experiment. Right? You got such a big error. First, there's no way to correct this. So go and redo the experiment. That's what you'll get it. So we don't have any formulas to, find out errors of such things. So we're not going to do this. So it's a very large error. Power rule is not valid. So keep that in mind. All the errors that we do is supposed to be for small. If you get really big errors, technically you are not supposed to use those formulas and yeah, supposed to redo the experiment. So this is fine. That's not fine. Clear with this? Let's see one more easy one. Yeah, questions are like this only kind of. We got a cylinder of radius r, 10.0 centimeters. Length L is 20.0 centimeters. Mass M is 40.0 kgs. Find error in density. So we took a cylinder of length L, radius r, and mass M. So what is the error in density? Now, if you notice here they didn't tell you what is the error. They gave only the decimals. So this is what they expect from you. When they say 10.0 centimeter, there is one decimal there. It is expected this will have an error of 0.1. So the number of decimals is the error. So sometimes they won't mention the error. So you have to understand that you can take the decimal as the error there. So they said length is 20.0 centimeter. So if it is 20.00, I'll take 0.01. So keep that in mind. Sometimes people feel like, it is not given, but the decimals is the error there. Yeah, let's get this. 0.75. Anyone else? Hey, again, so what is the density curve formula? Mass by volume. So rho is m and volume is pi r square L. Again, you can clearly see it looks like the power rule there. So d rho by rho is dm by m, 2 times dr by r plus dl by l. Yeah, you're done from there. So dm would be 40, that's 0.1 by 40, zero point 0.1 by 10 plus 0.1 by 20. How much is this? Multiply 4, that will be 8.9.11, 1.1 by 40. This is your d rho by rho. I asked you for error, I didn't ask you for percent error. So d rho will be rho into 1.1 into 40. Yeah, it's just length is that. So you have to get the Roca value from here and substitute and finish it off. And your Roca value here will be mass, which is 40 by pi r square is 10 square. So convert into meters. Centimeter is 0.2. That is your rho. Take this and substitute here. So I will leave it there. I should have asked you for percentage error. Clear with this? So they ask you simply error, they're asking me for d rho. Next one. So you should know your formula and then the power rule will work as long as the errors are small. This one is a good one. So we know the kinetic energy ka formula K is half mv square. Multiply and divide by mass. This will become mv whole square by 2m. So we can write the kinetic energy is equal to mv is momentum p square by 2m. Mass is constant. Find percent error in kinetic energy. When the percent error in P is 1%, 10%, 100%. In the exam, I'll give you 10%. Get them up. If the error in momentum is 1%, 10%, 100%, then what is the error in kinetic energy? Everyone should try. नहीं रोहित. So I told you something. If the errors are big, you can't use the power rule. But if the errors are still big, they will give you something simpler like this. Which you can get. I'll give you a minute more, then I'll show you. Yeah, let's see the first part. So what does the power rule say here? So kinetic energy is P square by 2m. So m is anyway constant. So percent error in kinetic energy is 2 times percent error in momentum. Great. So now if I just use that formula there, so the first one will give you an answer of 2%. Second will give an answer of 20%. The third will give an answer of 200%. Okay. Now, let's see, actually, if I try to do it normally without using the power rule, how do we handle this? Look at this. So percent error in P is 1%, meaning the momentum has increased by 1%. So the maximum possible value of P is 1%. So that can be, so P final can be taken as 1.01 P. Is that making sense? So it is 1% more than P. So it is 1.01 P. Then your final kinetic energy will be your final momentum square by 2m. This would be 1.01 ka square P square by 2m. This is 1.0201, the initial kinetic energy. So change in kinetic energy by kinetic energy, right, into 100. This would give you 0.0201 into 100. So this is actually 2.01%. So this is still acceptable, but 2% and 2.01%. That is the actual answer. Yeah, this is an acceptable error. Like, that error in the second decimal is fine. But when you do this for the 10%, so if your percent error is 10, then your P final is 1.1 P. Then your final kinetic energy would be 1.1 square by P square by 2m. That's 1.21 kinetic energy initial. So the change in kinetic energy by K into 100, that would be 0.21 into 100. And that is 21%. This would be a good question. And the answer will be 21. So this would be wrong. The answer is not 20%, it is 21%. So as the error becomes bigger, your power rule starts giving it'll start failing. It will not give a good value. And look at the third one. Third one is really messed up. You said percent error in P is 100%, meaning you have become double. So P final has become 2P. So kinetic energy final is 2P whole square by 2m. That is 4 times the initial kinetic energy. So change in kinetic energy by kinetic energy into 100. So change in kinetic energy is what? K final minus K initial by K initial. That comes out to be 300%. But here, if you use the power rule, I get 200%, which is wrong. Are you clear with this? So if they're going to give you big errors, they will keep the formula simple like this. They'll not give you that a power x, q power r, and all that stuff. So this question, they'll ask you the 10% one, because the 10% won't give you a doubt. See, if I say 100%, right, this might give you a hint like, oh, power rule is not valid. 10%, you might still think it is okay. And you'll get a difference of 1% there. So you'll have both the options, 20 and 21. 21 is the answer. A small thing, but be careful with that. Are you clear with this? So if your measurements have big errors, then things will start getting really messed up. Next thing. Any doubts so far? Anyone is not clear with anything? Clear, na? Manav, Ananya, Rohit, Tanishka, Tanmay, clear? Next one. In a simple pendulum experiment, a stopwatch of least count of 1 second is used. It measures 200 seconds for 100 oscillations. So you're doing a simple pendulum experiment. You took a pendulum and it is oscillating. And you counted the total time taken for 100 oscillations, and it was 200 seconds. So what is the least count? Again, this is one new word there. So least count is the smallest value that can be measured. So when you take the scale which you use in school, the smallest length you can measure is 1 mm. That is the smallest division. That means in this clock, the smallest time you can measure is 1 second, meaning you can measure 24, 25. You can't measure 24.5. There are no decimals in the middle. So the number just goes 24, 25, 26. So when you stop, either you get 24 or 25. You will never get something in the middle. So this is the smallest value that can be measured. And generally we take this as the error. There is more to it, but for now it is fine. This is taken to be the error. Now I hope you know how the experiment looks like. So we got a pendulum here, length L, and this thing is just oscillating. The length of the pendulum L is given as 1 meter plus or minus 0.01 meter. The time period for one oscillation, capital T, is given by 2 pi root over L by G. I hope you remember we did this formula in units and dimensions. Find the percent error in gravity. So I can actually use this experiment to find the acceleration due to gravity. You take a pendulum, you find the time period, you know T ka value, you know L ka value. From there, you can find G ka value, which is acceleration due to gravity. Get the error in percent error in gravity. Thing. So what Now be careful here. Huh? This is something else. This is the 200 seconds for 100 oscillations. Capital T is time for one oscillation. So first of all, when you do this thing, right, you want to find error in G. So the idea is this. First, you have to get G from the equation. 2 pi root over L by G, square it on both sides, T square, 4 pi square L by G. That is the thing. Don't directly use the error ka stuff. First, you get this on this side. This is the formula for G. It looks like power rule. 4 pi square is constant. So dg by G into 100. dl by L into 100 plus 2 times dt by T into 100. Now, what is this capital T? Now, this is important. See, it works out actually. So when you do 200 seconds, the error is 1 second. Now, this is important. The clock, right, when you're stopping it, it must have been like this. So when you stop the clock, you must have got 200 or 201 or 199. So there's an error of 1 second. So when the stopwatch measures 200 second, right, with an error of 1 second. So this is an error over total time. So that means for one time period, the error would be what? So this is the catch. So the error will actually split for 100 oscillations, isn't it? This is the reason when you do the experiment, you take a lot of measurements. Imagine this way. You do the measurement only for one oscillation. The time taken is 2 seconds and the error is 1 second. Error is 50%. If you do only for two oscillations, 4 seconds, time error is 1 second. So it doesn't matter. Anytime you stop the watch, the error is 1%. Is that making sense? So when you do here delta T by capital T, so this is nothing but delta time by 100, that is 100 oscillations, by the total time by 100. So here small t is the total time. Delta T is the error in total time. So basically that 100 is useless. It will always get cancelled. So you can remember this way in the exam. So delta T by T, directly you can take total error by total time. I hope you're getting the difference there. This was an error of 1 second for 200 seconds. But this is for 100 oscillations. That means each oscillation took you 2 seconds. And this 1 second error is for 100 oscillations. So each oscillation has an error of 1 second by 100. That 100 and 100 will always cancel out number of oscillations. So it feels as if the total error in time by total time is same as error in delta T by delta capital T. Is everyone clear what is capital T and what is small t? They're two different things. Capital T is the time period for one oscillation. So the error simply divides up. Delta T is the error in capital T. So yeah, and once you got that, you're done. So how much was this? 0.01 into 100. This is 1%, and that's also 1%, 2%. Okay with this? Hey, not a big thing, but you have to be careful. So because you got the error for the full time, they're asking you error for one oscillation. So you have to divide by 100. Even if you have not done that, you would have still got the answer. Next one. Now we have an experiment in mirrors, which is given by UV plus U plus V. So there is a quantity like this. F is called focal length and all. So don't worry about this. So let's say U is 10.0 plus or minus 0.1 centimeter. V is, let's say, 5.0 plus or minus 0.1 centimeter. Find error in F, or find focal length. This is a good one. I tell you something. See what people do. They will say, okay, we will take put log on both sides. Log F, log U, log V minus log U plus V. Basically the power rule. Differentiate df by f, du by u, dv by b minus d of u plus v by u plus v. Right? And then we studied that errors are always additive. And therefore you'll put a mod everywhere. Right? So be careful. This is wrong. You can't do this. The simple reason, if you look at the quantities here, now understand why we say errors are additive. Listen to this. For example, if you had a quantity like this, let's say some C or anything like, let's say P is equal to A by B. Now, when you say A is something like, 10.0 plus 0.1, and when you say B is 5.0 plus or minus 0.1, now you tell me, to get the maximum error in A, what should I do? For maximum error, what is the worst case scenario? A should be maximum. For maximum error in A, the pika value, right, would be A should be the maximum value. So that will be 10.0 plus 0.1, and B should be 5.0 minus 0.1. Are you getting it? So when that thing goes up, minus of minus becomes plus. That's why we say errors are additive. So when you do this dP by P is equal to dA by A minus dB by B, what was actually happening was this. You're taking dA is 0.1 by 10 and you're taking dB is minus 0.1 by 5. That minus minus becomes plus, and that's why you could add it. That was the reason why we said errors are additive. And this is fine because here A and B are independent of each other. So A ka value and B ka value do not interfere with each other. So it's fine. And so the power rule, right? This works when you are independent of this thing. But look at the problem here. Suppose the same thing, if I do like this, P is equal to A minus B by A plus B. Okay, now to get the maximum error, what should happen? For maximum error, this A minus B, so P will be like A minus B by A plus B. Your A ka value must be 10 plus 0.1. B ka value must be 5 minus 0.1. A ka value must be like what? This denominator must be minimum. So 10 minus 0.1. And B ka value must be like what? 5 minus 0.1. How can A ka value be 10 plus and 10 minus at the same time? You're getting the problem there. The numerator and the denominator are dependent on each other. When you say A minus B is maximum, you cannot make A plus B minimum. I hope you're getting that. So the numerator and denominator are independent of each other. For example, let's take the question which we have it. So when you say f is equal to uv by u plus v, for max error, u plus v by u plus v, this u guy must be 10 plus 0.1, v must be 5 plus 0.1, and the denominator must be minimum. So this is 10 minus 0.1, and this must be 5 minus 0.1. This is not possible. You can't do this. You cannot have different values for u and v at the same time. So these are dependent errors. So here numerator and the denominator are dependent on each other. So you cannot say errors are additive. If you make the numerator maximum, even denominator is going to become maximum here. So keep this in mind. Errors are additive only if the quantities are independent of each other. Errors are not additive. Then how do we solve them? You have to figure out a way to separate that u and v from each other. So this is what we do. 1 by f, reverse it, will be 1 by u plus 1 by v. Now see, you separated u and v separately with each other. Now differentiate this. This will give you minus df by f square minus du by u square minus dv by v square. Now your du and dv will be independent of each other. They don't interfere with each other. Now there is no problem there. So we get df by f, or df is equal to f square du by e square plus dv by v square. That's your error, everyone. So you have to find a way somehow to separate that functions u and v independent of each other, because now whatever the value of u, v will not interfere with this. Is that clear, everyone? Now let's just substitute the values there. So just be careful with that, dependent and independent errors. So we want to find the value of f. So 1 by f is 1 by u plus 1 by v. That's 1 by 10 plus 1 by 5. That's 3 by 10. So f is 10 by 3. Great. So df will be f square du by v plus dv by v. So substitute here. This is 100 by 9. 0.1 by 10 plus 0.1 by 5. So this is 1 by 9, and that's 1 and 2. That's 1 by 3. Therefore, f ka value is 10 by 3 plus or minus 1 by 3. Yeah, you can get it in 0.33 fractions and all, but that's the value of f. Clear with this? If you do this, you'll get a wrong answer. You cannot do this. You cannot take u and v as one term and u plus v as one term. They depend on each other. Clear with this process? Great. So keep this in mind. These are dependent errors. So let's see one last one on this. We have two resistors in parallel, R1, R2. Let's say R1 is a 20.0 plus or minus 0.1. 10.0 plus or minus 0.1. Find R equivalent. Let's finish off with this. Any answers? I hope you know the formula for a 1 by R equivalent is 1 by R1 plus 1 by R2. So that's a better way of writing than writing R1 R2 by R2 plus R1. Again, it becomes independent. You know the story, same thing, differentiate. That's how much? 0.5 by 9. That would be how much? Point 55555. You can round it off up to two decimals. Like how many significant figures are there? So your R equivalent will be 20 by 3, which is 6.67. There are three significant figures, so plus or minus. This is also 3. So this is a 5 and the number before it is odd. So this becomes 0.56. That's your error there. Clear with this? Yeah. Hope you remember rounding off, right? If you have a 5 and the number before is odd, you increase it by 1. That would be a final answer. All clear with the stuff? This is another type of errors, like, the dependent errors and everything. So More on this we will see again later on. Once the portion gets over, we're going to do it again. Errors in more detail. Yeah, I'm going to teach you then vernier calipers and screw gauge and instruments and other stuff. But for now, I think this much is sufficient to handle most of the things. Again, not a big chapter, right? I'll send you a sheet also now after the class. You can try that. Maybe another 20, 30 questions. That should take care of the whole thing. So that with that, we're done with this thing. So the next one is loss of motion. NLM. Now, this chapter, right? Primarily, there are only two main things. One is your constraints. Second thing is your free body diagrams. If you are good with these two, then you can say more than 50% of the chapter is done. So we will go one step at a time. Instead of dumping everything, I would prefer to go one at a time. So we'll focus first on only constraint, then we'll go focus only on FBDs, then we'll combine everything. So first thing is constraint motion. And quite an important chapter. Like I keep saying, NLM is like the mother of mechanics. Your NLM is bad, you can forget about the rest of the mechanics. So everything gets connected from here. So whatever we do, they're all related to things going ahead. So constraint motion. So what is a constraint motion? The motion of a body depends on motion of other bodies. Meaning, if someone else decides to go with a certain velocity, right? You don't have an option. Basically, you're dependent. The motion is said to be constrained. Think about this. When you're walking on a road and there's a pigeon flying in the air, because you are walking on the road, does the pigeon in any way get restricted? It does what it wants, you do what you want. But what if you're taking your dog for a walk with a leash? Right? You're strong, you will drag the dog. The dog is strong, it will drag you. Both are constrained. Right? It is said to be constrained. So just to give an idea, right? When you say dependent and independent, what do you mean by that actually? See, simple example, if I have to tell you, let's say I have 10 apples and there are two people, A and B. The only condition is I have to give all the 10 apples to A and B, right? I have to give all the apples to A and B. The moment I say A has three apples, does B have a choice? There's no choice, meaning the moment I decide one person ka value, the other person ka value is decided. So even though it feels like there are two choices, in reality, there's only one choice. Suppose if I say there are 10 apples, I can give any number of apples. So if I give A ka 3, B can be 0, 1, 2, 3, 4, 5. You have options, right? So that is the meaning of dependent and independent. So the moment you decide the value of one guy, and if that decides the values for others, they are dependent on each other. So example, let's say we got a block A here, and let's say this is going with VA, 5 meters per second. There is some other random block here, B, and this VB can be anything. B doesn't care what A is doing, right? So here motion of A is independent of motion of B. So this is not constrained. But the same thing, you have A here, and let's say the both are connected by a rod. Let's say the rod can't break. Now, the moment you say this B is going with 2 meters per second, A really doesn't have a choice. since the rod is rigid, A has to go with 2 meter per second. Yeah, we are not taking any rotations and all that stuff. VA is equal to VB. Motion of A is constrained. That's it. So the moment you decide the value for B, A does not have a choice. As simple as that. Now in constraints, right, you can say there are three things like case one and method two are kind of same. So there are kind of three methods to do. So method one, it's good theoretically, but we will not use it, but let's learn it. It will be helpful. So the first thing is your string constraints. I will go one step at a time. So the idea is simple. Whenever you have a string connecting a blocks, an ideal string length cannot change. So what is an ideal string? So these ideal strings are inextensible, meaning no matter how much force you apply, they don't stretch, they don't break, they don't dissipate energy. Which is not the case in real life. And massless. Inextensible. No matter what you do, it doesn't stretch. So method one is pretty straightforward. Method two is much better, but it's good to learn. That's it, nothing else. This will help you for method three. Gives you ideas. Idea is very straightforward. If you take a string, the length of the string cannot change. Best way, let me show an example. You will understand. That's the whole concept behind it. So let me take a very simple example. Let's say we got a pulley and we got a block. This is A and this is B. You can see and tell, right? If A goes up, B comes down. It's very easy to see this and tell, but let's see how to do this generically. Let this length be X. So basically this is the X is the length of this string. Let this be Y. Y is the length of this string. No matter how much A and B moves, the length of the string must remain constant. So X plus Y is equal to L, which is constant. Differentiate on both sides. Then this will be dx by dt plus dy by dt. Since L is constant, this is 0. Now ask yourself, whenever A goes, what will change? X will change, so dx by dt is VA bar. Whenever B moves, Y will change, so this is VB bar. Yeah, this looks silly because it looks so straightforward. But you get VA bar is equal to minus VB bar. So what we got here is the negative sign indicates if A goes upward, B will go downward with the same speed. So there we found a relation mathematically between A and B. Negative indicates A and B move opposite to each other with same speed. Yeah, it looks easy because there are only two blocks. Let's take it from here. Slowly we'll bump it up. But is the process clear how we approached it? We said let the length of the string be X, let the length be Y, total length is X plus Y. This length cannot change. That was the whole idea there. Let's take one more example. That was pretty easy to see and tell. There was no need to do so much work. But what if you have something like this? Now you have A, B, C. So suppose if A is going up, can you confidently say B is going down and C is going up or something? Now it starts getting confusing, isn't it? When you had two, there was no problem. But when you have three or even four or five, now it starts feeling like I don't know what is happening with each of them. So again, we start the same story. So let's say this length is X. Let this length be Y and this length be Y. We are ignoring this curved parts, and let this length be d, z. Same story, x plus 2y plus z is L, which is constant. The total length of the string cannot change. Differentiate. You get dx by dt, 2 times dy by dt. So here you're assuming all are increasing. So see, in mathematics, right, we always assume functions are increasing. So VA, VB, and VC. This is the relation between them. Don't look at them and think like, oh, all are positive. No, all are not positive. So let me give you this with numbers. You will see how to use this relation. Those are vectors. They can have any directions. Look at this with the numbers. Let's say A is going up with 2 meters per second. And let's say B is going down with 3 meters per second. And then they ask you find the speed of VC. Now apply in the formula. Up is positive, down is negative. You can take any convention here. So VA will be plus 2. VB is going down, so 2 into minus 3. That will be VC bar. So this will give you VC bar is 4, a plus 4. So this indicates it's going up. Is that making sense? So now if I know what two things are doing, I can tell what is the third one doing. So this is the meaning of a constraint relation. The moment you decide the value for A and B, C does not have an option. C has to take that particular value. Is the story clear, everyone? This is your method one using length of the string is constant. Now I'll give you one like this. You guys try. We won't use this method for maximum number of questions. There is a much better ways to do, but this will give you that perspective like this. What about the strings which hold block B? See now, when B moves, what changes is this length, right? Ahana. This length will anyway never changes. That is just a support string, isn't it? It won't matter there. Think about it. When C and A move, does this length ever change? It won't matter, right? So if that looks confusing, think of like this. Now, this itself is B. Does that change anything? So basically, that part of the string is just a support. It is useless. The same way, are you worried about these strings here? You're not worried about it, right? Because they were useless. They're just to support you. The same way, this is also the same thing. It won't matter. Clear? So all you need to look at is this. When A, B, C are moving, how is this string changing? So we are looking at this part. This is the length of the string which is changing. Got it? So we are saying that length is constant. Let's say C is going up with 2 meter per second. A is coming down with 3 meter per second. Find VB. You got an answer? You can type in the chat box here to the co-host. I just said hi. You can type your answers there. Mm, 1/3. Okay. Anyone else? Start like this. Let this be x. So when A goes up and down, only this length will change. That is how you see. But when goes B goes up and down, this will change. This also will change. So this is y and this is y. When C goes up and down, this will change. This will change, and this will. There are three lengths changing: z and z and z. So just visualize there. When it goes up, what are moving? For example, see if B and C are at rest. If A goes up and down, only this length will change. If A and C are fixed, and when B goes up, only the red ones will change, and so on. So the total length of the string is x plus 2y plus 3z. Differentiate. Velocity of A, 2 times velocity of B plus 3 times velocity of C is 0. A is going down to minus 3 to VB. C is going up 3 to 6. That would be 6 minus 3. That's minus 3. Minus 3 by 2 meters per second. Minus indicates it is going down. Please check. Yeah, right, Aniket. Right, Karthik. All clear with the steps. So when you have more than two moving, then you'll actually see things will does get messed up. Let's see one more. This is another classic problem there. This is theta there. Let's say B is going down with U. A is always sliding on the floor. A does not lift off from the ground. Find VA. Like I said, the method two will do, you'll get the answer in 2 steps. This is still lengthy, but let's give it a try. Find velocity of A. So B is coming down and A is going to the right. Let's use this length method and see if you can get it. The reason why I like method one, right? It teaches you how to visualize. That's useful. Method two will give you answers even without any understanding. So that's okay, but better we know. How do we do this like with this length and all? The story is still the same. The length of the string is constant. So keep that in mind. So let this be X. Let this height be H. And let this length be Y. And this length here will be root over H square plus X square. So here the length of the string is the hypotenuse plus that extra tail Y. Because when B goes up and down, this length will change. When A goes left and right, this hypotenuse will change. That's your length of the string. Now differentiate. This would be 0. Chain rule, 1/2 root H square plus X square. Differentiate inside, you get 2x dx by dt plus dy by dt. So this would be dy by dt. Now here, look at this thing here. When a is going this way, is x increasing or decreasing? Now this is important. So dx by dt is minus va since x decreases. Technically, we should have done that for the previous one also, but it works out because you're taking all positive and all negative, right? And what about y? When b is coming down, y is increasing. dy by dt is plus vb since y increases. If you see, we did this in rate of change in calculus. Signs will matter. So now this would be x by root over x square h square is your cos theta, and dx by dt is minus va. This is your vb. So we get va is equal to u by cos theta. Clear with this? This is not u cos theta. Clear how we did this thing? This is method one. You figure out the length of the strings with x and y, and then you differentiate it. Any doubts on this? Take a break. Come back by 9:45. We'll continue from here. Any doubts so far? Chill. Come back by 9:45 then. Next one. Method 2. No, they also call this thing, we can do something called virtual work method. I like to call it power method. So we will simply say power method. It doesn't matter, it works. So what is the idea here? Comes on everyone. Since we are taking ideal strings, they do not take any energy for themselves. That means the strings are simply a way for energy to transfer from one point to another point. There, that's the main catch there. So ideal strings transfer energy from one point to another point. Comes on everyone. Therefore, the total work done by the tension is zero because they don't take any energy, simply transfer it. That's the concept behind the virtual work method. So the strings don't take any energy. Now, if they're not taking any energy, that means the power is also zero. This is what makes it even better. Total power due to tension is zero. So we need to know a little about power. Power is simply work by time. So rate of change of work. And work done is simply F bar dot dr bar. And dr by dt is F bar dot v bar. So this much know the formula. It is okay if you derivation and all. We are going to do it later on in work per energy. But the power curve formula is given by force dot product v bar. So power is simply the dot product of force and velocity. We will combine this. We will see the whole thing. Now, before jumping into this, we will talk a little about tension. So how does this tensions behave basically? In more detail, we'll do it in FBDs, but you need to know a little. Any doubts on this page? So what do strings do? Strings always pull as. So if you take a block M here and leave it there. So the strings, what they do, the string is pulling the block up. The string is also pulling the ceiling down. So if you take the block M, so imagine like this, huh? Someone is catching your hair and pulling you. What is that hair doing to it? It is pulling you up. So T is the tension force due to the string. So basically strings always pull. The same thing, if you look at the ceiling perspective, the ceiling will think, Arya, the tension is pulling me down. So it string always pulls. So whoever is connected to the string, it will pull them. So if I pull you with a rope, the rope is pulling me and the rope is pulling you also. Tension pulls ceiling down. So strings will always pull. Strings cannot push. The moment you try to push, string becomes loose. And if I have to just show you, If this was a string and let's say you're catching this and you're pulling it, the person pulls the string pulls him back. So, but if you try to push, the moment you push, the string will simply become, slack. There'll be no tension. The string becomes loose. Yeah, it looks silly, but important thing. There'll be no tension. So keep this in mind. So that's the difference between a string and a rod. We will talk about that rod later on. This idea is clear. So there are two things. Strings always pull. Second thing, power is F bar dot V bar. All got this? Next thing, relation between the tensions. Again, this slightly goes into the FBD territory, but we can see this. Relation between tensions. Let's say we have a pulley like this. Now look at here carefully. Yeah? There are different strings here. This whole thing, the green one is one string. This whole thing, this red one is a different string. These strings are different. So the string will pull with this thing T1. This green one is pulling with T2 and T2. So if I actually draw this pulley in the middle, look at the forces here. The red one is pulling up. The green ones, like I said, the strings always pull T2 and T2. This is pulley 1 and pulley 2. So meaning one tension T1 is being balanced by 2 times tension T2. We are assuming pulleys are massless. So there is no mass to the pulley. So if you have two ropes pulling one string, tension becomes double, right? If I give you one more example, now look at this here. This whole string is the same string, the red one. This string is another one, green one. So if you draw this big pulley, you will see the red string is attached at 3 points. It pulls at 3 places, T, T, and T. The green one will only pull single string, T2. So we can clearly see 3 times T1 is equal to T2. Are you guys getting this relation? Again, we're assuming all are massless pulleys. There. These are the three things you should know. First thing, power is F bar dot V bar. Strings always pull. If you have multiple strings, what is the relation between them? So one string will have one tension. All clear with this? So how do we use this to solve now? Steps to solve. Always remember the process. It's okay, you don't remember the problems. If you remember the process, you can, any type of problem you can start. So first thing, label the tensions. If there are 5 different strings, call them T1, T2, T3 or whatever, and find relation between them. Second thing, find power on each block due to tension. So power ka formula is T bar dot V bar. So T is tension here, which is TV cos theta. So you can write this thing as T cos theta into V or T into V cos theta. Uh, so T cos theta is the component of tension along velocity. Third, the total power is 0. So power on the first block, power on the second block, and so on until power on the nth block is 0. So T1 bar dot V1 bar plus T2 bar dot V2 bar, so on until Tn bar dot Vn bar is 0. There are certain restrictions on this, but I think we'll see that in the end. First, let's see this thing. This is the tension on the nth block. This is the velocity of the nth block. Are the steps clear, everyone? Let me show you the example. In method 1, the things we did. Now, if I use the same method, see how it works. And you will see how easy it actually becomes. There's no headache of that, all that tension, and everything. Let's say this is going up with 2 meter per second. Let's say this is going with 3 meter per second. And this velocity, we don't know. Step 1, label the tensions. If you see this entire string, it is the same string. So this will be tension, this will be tension, this will be tension, this will be tension. Now you can clearly see, right? These 2T is acting on this only, so it is the same tension there. Step 2, find the power on each block. Let's call this block A, B, C. So power on A, T into 2, both are in the same direction. Power on B, 2T into -3. Power on C is T into V. Total power is 0. 2T minus 60 plus TV is equal to 0. T goes off. V is equal to 4 meters per second. Making sense? The other one, the angle one, look at that. That becomes even better. Step 1, label the tensions. So this is being pulled. This is being pulled. That's what I'm saying. Strings always pull. This guy is going down with U. This guy is going with VA. So power on A plus power on B must be 0. Power on A, remember, there's an angle between them. T, VA cos theta. Power on B, T is upward, velocity is downward, T minus U. VA is equal to U by cos theta. No length, no differentiation, nothing. There is no confusion of cos theta is there. This will always give you the values. Clear with method 2? Now, few things here before jumping into the problems. Method 2 has its own problems. Something is really easy, you'll always have issues. So method 2 actually gives incomplete answers. That's where method 3 comes. We'll see that in the next class though. If there are forces, if there are other forces responsible for power transfer. So the whole idea here was the total power is coming because of tension. But if there are other forces like normal reaction or something which are responsible for the power transfer, you won't get complete answers. So just remember this thing. When it comes, I'll show you. That way it will actually trigger what it means. Method 2 is valid for velocities. And if you want to use this for acceleration, this also I'll show you later on. If the angle between tension and velocity remains constant. Don't worry about this two statement. Just have an idea, like they look a little vague, but when they come, I'll show you. Then it will actually trigger. Velocities does not change. So this was the idea there. T1 bar dot V1 bar plus T2 bar dot V2 bar. Tn bar dot Vn bar is 0. Differentiate with respect to time. Then your acceleration here becomes T1 bar dot A1 bar, T2 bar plus A2 bar, and Tn bar dot An bar. So you can actually use this for acceleration also. But there's a small thing there, which we will talk about it later. But anyway, the steps are clear. Great, let's see some questions then. You can use this power method. A is going up with you. Find VB. Find VB. The question is bigger. The answer is actually much easier. The blocks come in contact. Yeah. If the blocks are touching each other or there is something there, it starts giving wrong answers. मतलब बाद में देखेंगे. You'll have cases like this, where the block is here and the string is here and something like this. If you see there's a normal reaction here, then you won't get complete answers. You'll start getting some issues there. So we will see those things in the next class. But now everything is just hanging in the air. Any answers? 8U, 7U. Okay, let's see. Step 1, label the tensions and find the relation between them. You can start from anywhere. I will take this as tension T. Now look at this. If this is T and this is T, this will be 2T because there are two strings. If this is 2T, this will be 4T because 2T, 2T is 4T. This will be 8T. This will be 8T. So the total power here will be 8T into U plus T into VB. So we get VB is equal to minus 8U, means it is going down. The signs will take care of themselves. Same thing here. If this is T, this is also T because it is the same string. So if that is T and T, then this is 2T. This is the same string. So this is also 2T. If that is 2T and 2T, this is 4T. And this is the same string. So on A, we have total 4T plus 2t plus t, the total tension, into U plus T into VB. So VB is equal to minus 7U. Minus means you're going down. All clear with this? Easy. Get the tension, get the velocity, multiply, and you're done. Any doubts on this? Let's see. This one. So we got a man there and he's pulling both the strings with speed u, meaning this part here is being pulled with u and this part here is also pulled with u. Then he's asking what is the velocity of this big block. Be careful, huh? There are two different strings. Yeah, let's see this thing. Now, if you carefully observe here, right, this entire string here, this is one string. This is a completely different string. So if you say the red one is tension T, so the string is pulling him T, this will be T, this will be T. So strings always pull this thing up. So this is T, 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 and T. So the green one will be 2T. So this person, right, the tension is different on both the hands. It's not the same. He is being pulled with two different tensions. Yeah, somehow he's staying there. Technically, he should have moved, but now if you look at the power on the man, look at this point here. The power on the man will be 2T minus U, both are opposite. T minus U, so it's minus 3TU. And look at this block here. Huh? 1, 2, 3, 4, 5, 6. There are 6 tensions which is pulling the whole system up. 60. So you're done. So minus 3TU plus 60V is 0. Karthik, this one.
Sir, one more slide back.
Hmm.
Yes, sir. Okay.
So most common mistake, right? People take both the sides T. So just be careful with that. The string is different. Got this? Any doubts on this? Clear, na, Soumya? Shriya? Tanmay? Rohit? Aniket? Ananya, Dhruv, clear? Let's see one more. We got a ring here. We got a block here, A. We got a block here, B. So we have a rope here which is passing through this ring, and it is attached to this block. So here the string passes through the ring. It is not attached. Let's say VB is going with 2U. The ring is going horizontally with, let's say, some speed. Maybe I can give you some numbers. 2 meters per second. Let's say this is going with 1 meter per second. At this instant, these angles are 60 degrees and 30 degrees. Find velocity of A at this instant. So the B is moving forward, the ring is also moving. So there are two ways to do this, but yeah, that's it. The standard question is when the ring was fixed. That was the standard model. So this ring slides on a horizontal rod. Any answers? Okay, Karthik, Anish, that looks right. So one way to do right is just use the method I said. Second thing, you can actually stop the ring. That's another way to handle that. You can stop the ring and then you can solve in relative frame and bring it to ground frame. Can be done, but let's follow the process. Step one, find the tensions. So this is pulling with here tension T, this is pulling with tension T, this is pulling with tension T, this is pulling with tension T. Strings always pull. Next thing, get the angle. So this angle would be 30 and this angle would be 60. So if you look at the ring here, remember I told you that T is the tension along the velocity. So this is T cos 30, this is T cos 60. So you can directly do this. The ring will feel as if, the string is pulling at that angle. And this is your 1 meter per second. You're done. So the power on A plus power on ring plus power on B must be 0. So power on A is T VA cos 60. power on ring is the total tension along the velocity, that is the horizontal, which is T cos 30 minus T cos 60. The signs will take care of it, and velocity is 1. This is pointing backward, so minus T cos 30 into 2. Or you can say T1 cos 50, but that is same thing. Tension cancels everywhere. This is V by 2. This would be root 3 minus 1 by 2. This would be root 3. Hmm. How much is this? That will be root 3 minus root 3 plus 1. All clear with that? There, so you can just take the tensions on everything that you have and finish it off. Any doubts on this? Or you can stop the ring. Then the ring will think this guy is going with 1 and this guy is going with VA minus 1 and same. So it will work, but same thing. Any doubts on this? So the process will work. Get the tensions, get the components, find the power, equate to 0. Let's see. One last one for the day. We got a ring. We have a tied to a block here. So this is it. Ring slides on a horizontal rod. The ring is going with speed u. Here to here, this height is h. This angle is theta. VA is going down. We don't know the velocity. Ring slides on a horizontal rod with speed u. Find velocity and acceleration of the block A at this instant. This is a good one. Good more than one choice question. Let's go. Finish off. Last one for the day. How we do this? Get me the acceleration value, everyone. That's the main one. Velocity is still fine. So for velocity, the story is still the same. Get the tensions and finish it off. So step one, draw the tensions. The string is pulling up. The string is pulling at an angle. Power is 0. So T u cos theta minus T VA is 0. VA is equal to u cos theta. Great. You're done. So we got VA is equal to u cos theta. Now if you differentiate this with respect to time, people say, okay, this is dVA by dt. This is du by dt cos theta. But then since u is constant, they will say this is 0. So this should be like what? Acceleration of A is equal to the acceleration of the ring cos theta. So you have to be careful here. If you do this, this is wrong. This was that second thing which I wrote. The actual differentiation was this. Here, theta is also variable, isn't it? Theta is also variable. Cos theta is not constant. That's the reason I said you can't use this for acceleration. So when you actually differentiate this, this is dVA by dt will be du by dt cos theta plus u into d cos theta by dt. Theta is variable. So that was the statement there. If theta was constant, you can use it for acceleration, or else you'll get the second term. U is anyway constant here, so this guy is gone. So if I actually write the whole formula, right, this is how it looks. Acceleration of A will be acceleration of the ring. In this case, it's not there, but plus u into differential of cos theta is minus sine theta d theta by dt. This is the acceleration of A for the relation. This is 0 since u is constant. So we have acceleration of A is minus u sine theta d theta by dt. So if you can find d theta by dt, my job is done. Any doubts on this? So be careful with this part here. Yeah, use it for acceleration if you're sure that theta is not changing. You see theta changing, don't. Velocity के लिए it is valid. There is no problem for velocity. Now we need to get the d theta by dt. A bit of a geometry here. So let's get this triangle here. This will be x, that will be h. You can neglect the size of the ring. So we have tan theta is equal to h by x. Differentiate on both sides. Tan ka differential, sec square theta, d theta by dt. There, this is where you get the d theta by dt from. H by x is minus h by x square dx by dt. And be careful here, x is going towards there. So dx by dt is minus u because x is decreasing. The rate of change of that x distance is u, and that is minus u. So we get from here d theta by dt is equal to h u by x square sec square theta. That will go to be cos square theta. But what is x? X is h by tan theta. Substitute here, that will be h u by h square. Tan will go up, so that will be sine square theta. Perfect. So acceleration of A is minus u sine theta d theta by dt. Substitute here. This would be minus u square by h sine cube theta. This is your acceleration of A, everyone. You ask velocity, it's a pretty good mains question. The moment you ask acceleration, it becomes something else. And the main headache is because that theta is changing. Are the steps clear, everyone? That's how you get theta from there. Any doubts on this? So later on, when you do circular motion, right, this d theta by dt is also called as angular velocity. So basically, this rope is also going like this. So that rope is actually rotating. They can ask you that also, angular velocity of the rope, something like that. Any doubts on this thing? Please ask me. Clear with this? So that's a beta about it. So next class, when we catch up on next Monday, we'll continue from here. We will do few more models on method 2, then we'll go for method 3 also. So yeah, I think another 1.5 class, we'll finish all the constraints and then we'll go for FPDs. So that is the thing. So we are actually finding relation between 2 or 3 or multiple blocks. One thing moves, we find the other one. I'll send you a small sheet on this also in units and dimensions also, so you can try that. So okay, with that, we'll wrap up for the day. So and do remember, there's a test online on Friday. Make sure to give it. So any doubts, anything else, please stay back and or else you're free to leave. So take care, stay safe.